Hello and hi, my name is Yashini Selvanathan and I'm from University Malaysia Pahang. So basically in this video I would like to talk about my paper, which is the title A Statistical Study of Factors Affecting Natural Biovinegar Fermentation from Pineapple Peel Waste, which I plan to publish in Material Science and Engineering through the conference iScience 2020. So for this video, I would like to talk about 6 things, starting from introduction, methods and method, results and discussion, conclusion, acknowledgement, and reference. So for the introduction, so basically we are producing biovinegar, which is a sour and sharp liquid that made of agriculture origin and must contain starch, sugars, or both by the process of double fermentation. So basically around 30 to 50% of total fruit weight were discarded every time in the food industry, and around 150,000 kilogram of waste produced each year in Malaysia. So this is a very big number, and the pineapple waste do have abundance of nutrients. So it is such a shame just to throw it out. So it's better we convert this waste into value-added items such as biovinegar. And did you know that in this study we are using mixed strains, which mixed strains way much better than single strain fermentation. And it does contain medicinal properties such as antioxidant, blood glucose controller, anti-cancer agent, and many more. And we are making use of full factorial design, which minimum of time and loss of factors can be considered through the screening phase. So for this study, we investigate 2 factors, which were objective 1, to screen and evaluate the significant parameter which affected the natural fermentation of pineapple peel biovinegar. And for the second objective, characterization and comparison of pineapple peel biovinegar with commercial biovinegar. So in this study, we do have 4 segments of methods and method, starting from substrate preparation, and then screening process with full factorial design, biovinegar fermentation setup, and then analytical methods. So if you have more doubts or you want to know more, so it's better you read my paper that will be published soon. So for the experimental design, so we are making use full factorial design, and the parameters that we have investigated were 6, starting from temperature, addition of glucose, fermentation time, condition of phase, condition of fermentation, and finally addition of yeast. So I would like to read a quote quoted by Bill. "Don't tell people about your plans, show them your result." So this is my result. So basically these 3 big numbers, that first is 50.83, shows that this model F value, which implies the significant, and the coefficient of determination around 0.9948, which is quite high for biological experiment. And this biovinegar produced acidity of 3.03%, which shows the validation error was only 3.04%. So for the factors and the contribution, we found out that there were 3 factors which shows higher contribution, starting from condition of fermentation and goes to temperature, then addition of glucose. So for the characterization, according to the physicochemical properties, this is the result. So we found out that the acidity and acetic acid contents do have higher in dates vinegar compared to the other biovinegars. But then if we compare to the quality, that according to DPPH radical scavenging and ascorbic acid, pineapple peel biovinegar stands second highest after apple cider and dates vinegar. So same goes for the ascorbic acid concentration. So this shows that even though the pineapple peel biovinegar do have lower acidity compared to the commercial biovinegar, but then it doesn't lack in terms of quality. So we came to an end, which for the conclusion that I would like to I would like to say that we successfully produced pineapple pea bio-vinegar with the acidity of 3.03%, and it is comparable to commercial bio-vinegar such as apple cider and dates. Pineapple pea bio-vinegar stands the second highest to the apple cider vinegar in terms of quality such as DPPH radical scavenging activity and ascorbic acid content. So I would like to talk about my acknowledgements. So I would like to thank Ministry of Higher Education for the FRGS grant and also UMP Industrial Grant RDU 1903114. So this is the reference that I have used during this slide. And if you do have any question, any doubt, so please feel free to email me through selvanathan@gmail.com. So that's all from me. Thank you. So please do read my paper that will be published soon in Material Science and Engineering.